Thank you very much. I first have to apologize for not attending the dinner last night, but I'm trying to avoid arbitration proceedings in Canada for one of my clients. So I was listening with interest to some of the presentations yesterday. So, artificial intelligence, big data, and EU law, what we're actually talking about is the relationship of technology to law and the relationship of law to technology. And that has always been part of so-called industrial revolutions. For instance, the first industrial revolution had the problem that, that the steam engines of trains threw sparks. And these sparks, while they're racing through the countryside at 20 miles an hour, were setting the fields on fire. And you had that legal issue all over the place. Who pays for those burning fields? And you have that in all the industrial countries. So if you look at the high court decisions in Germany, in England, in France, in the US, in various states in the US, you always have the same issues. They had this new technology, and they had to find a way of solving this economic and social problem. And what you do in the end, you're discussing liability, you're discussing chain of events, responsibility. Is it need a personal fault, or is it enough to set the conditions that then cause the damages? So these are the issues that we're also going to be dealing with when artificial intelligence starts running things and, as always happens, at some point causes damages. And so it'll be the same principles, the same legal issues that we've had since the first industrial revolution. And if you want, you could actually take some homework with you, and that is compare these different high court decisions for steam engines. And then you'll find a way of maybe dealing with autonomous cars and things like that. Okay, but the law also shapes technology. Product liability is the most important aspect, of course, because without product liability, cars would be far less safe than they are today. Or EU Data Protection Directive, and how Facebook is going to have to change and is already changing its business. So law does shape technology, but technology also shapes the law. So that's the overriding, you could say, legal philosophy of this subject. And in democracies, obviously, law is passed in a democratic process with different interests being expressed, and that is then also something. So we, of course, as lawyers know that everything is at some point interest-driven, but what's also important is to get at least a general understanding of the technology. And so that's what I'm going to do now. I'm going to go through these three words: AI, which is artificial intelligence, big data, and EU law. These three are labels to mysteriously complex systems. So that's what they all have in common. So we think we understand what it means when we read these labels, but of course, especially as lawyers, we might understand more of the law, but the issue is, how do I deal with the technology? And what I'm going to try to do is pick out the aspects that, as far as I can see today, are of legal relevance. So, the next slide is, what is artificial intelligence? Interestingly enough, we have an exact event and an exact date where the word artificial intelligence is defined and discussed and used as it is today to actually generate funds. So artificial intelligence is not the actual issue, but that is what this complex is called. And the event was the Dartmouth Summer Research Project on Artificial Intelligence in the year 1956. And in 1955, the application for the funding of the $13,000 that were needed was sent to the Rockefeller Foundation, and the term artificial intelligence, that caught their imagination, and that triggered all the funding that came after it. Pentagon, CIA, Soviet Union got involved, everybody on the military side wanted artificial intelligence, and if you labeled your research project as being related to artificial intelligence, you got the funding. It also created an avalanche in the cultural sphere, and we'll go back into that. So how we think of artificial intelligence is actually formed by films and novels. And EU law is also formed under that, as I'll show later. So what it was is 2 months, 10 people studying artificial intelligence. And then we have what you can call the actual definition of artificial intelligence, and that is the aspect of learning or any other feature of intelligence can in principle be so precisely prescribed that a machine can be made to simulate it. So we're trying to find aspects of human intelligence that we can then program, now that's the modern word, program into a machine, which nowadays of course is software. And in the next sentence it says, an attempt will be made to find out how to make machines use language, form of abstractions, nowadays that's of course mathematics, and concepts, so mathematical models, to solve kinds of problems now reserved for humans and improve themselves. And improve themselves, that's actually the important phrase. The machine improves itself. And so that is why artificial intelligence is actually self-learning software. So that's the actual term to use. And it's important to use that because you're now starting to understand what the technology actually is about. It's about software, and I have attributes in the software now that I didn't have before that enable the software to go beyond what the software has as programming. So you hear about algorithmic trading and all, or algorithms. Algorithms are nothing else than the instructions to the machine. And that's been around since Turing. So since in the 30s computer was invented, that's the Turing principle. You have a model, a mathematical model that you then put into software as programming. Nowadays it's different than in those days with the punch cards. So we're talking about 1955, artificial intelligence, when to program a computer, you had to punch hundreds of cardboard pieces and to then put into the hardware. That was before you actually really had software. So since then we've developed software. And if you think about it, okay, let me first give an example. So just to see the leap and what self-learning means. So in 1997, Big Blue, that's a computer from IBM, they programmed it to play chess. And what they did is they took all the possibilities of combinations of how you can move the chess pieces and programmed that into the computer. And every time the computer then makes a decision of what move to make, it goes through all of these. It's not that difficult because it's only a few hundred, and that happens within a second. So that's sort of we call that brute force. It simply goes through everything. And these are what humans told the computer how you play chess. Okay, and that, of course, with the best chess player of the world. So that was all inspiring and everybody was amazed and wow. Okay, the next game would be Go, because chess is actually quite simple in comparison to Go. And Go is a national game, national sport that you play in Japan, China, and Korea. And it's far, far more complex because you have a far larger board. In theory, you can take a whole room. Generals used to be trained in strategic thinking in China, in ancient China, by playing Go. And you have a lot, far, far, far more possibilities of combinations and how to move your pieces. So, in March 2016, Google had developed software to play Go, and it beat the best Go player in the world, a South Korean, 3 games to 0. And what they had done is they had trained the software by programming games, prior Go games, so that it could learn from examples. Okay, that was very, very impressive. A year later, we then really have self-learning software because they programmed another computer, and this time they only gave the computer the rules of Go, not a single example of how to play Go. Not a single example, just the rules. And the computer played against itself a few days, and then that computer beat the other computer that had learned how to play according to examples, thousands of examples. So what we now have, and that is sort of scientific, we have software, at least in this example. You just give it the rules, you don't give it huge amounts of data, you don't give it examples, and it's better than anything else. And also then again, of course, it beat the best Go player of the world. So that is the now. This is 16, 17, this is now. Just, we have a real example of self-learning. Okay, now of course, and what's also interesting just from a business aspect, so Google, and this is important because later we'll be talking about competition law, Google was able to do this because they bought a startup in London in 2014 that was called DeepMind, and they paid $400 million US for it, and there was a little competition with Facebook. So Google paid more than Facebook, and so Google got it. So what we have here as an example is, so you pay $400 million to have the best software to play Go. But still, what this example does, it shows that the theory, and this is what artificial intelligence or self-learning tries to do, and it tries to do deep learning. And deep learning is what the human mind does when it learns. And we don't really understand how the human mind learns. But at the same time, we're doing brain research. We're also building software based on the principles of deep learning. That is how the mind functions. So the gap between science and product is starting to really get very narrow. And that, of course, is also an issue when you're talking about warranty and liability. Software was always at the forefront. I mean, no software is perfect, but you always had products that were not perfect. You have product liability, you have warranty, but that doesn't matter. Still, the software industry has one major characteristic which is different from other industries, and that is, even if it's not finished, we want to earn money and we throw it on the market because no one else has a better product. So that is definitely something to keep in mind when you're discussing legal issues and artificial intelligence, is you do not have an industry standard yet. You do not even have a scientific standard yet because you're at the forefront of everything. Those building products are actually also by building the product, are doing the scientific research for the product. So the question is, why the sudden surge of artificial intelligence, and that has to do a lot with advancements of computer technology. So the GPUs nowadays are so good that you can easily do parallel processing on a laptop. And if you think about it, when NASA was planning to fly to the moon, they used slide rules to do the math of how much the fuel would weigh so they could get to the moon and back. They used slide rules. Later on, they did check the thing with computers, but you have to think that, you know, a computer now, at that time, it took days to program it. For each issue or each question had to be specifically programmed. And so it was simply faster for them to use slide rules. And if your smartphone has far more computer power than NASA had end of the 60s to fly the rockets to the moon, get specifically to where they wanted to land, and by the way, get back. That was the major issue, getting back. Okay, so the unending, nowadays infinite storage possibilities through cloud computer. Well, cloud computer is simply connecting hundreds of servers that are there anyway. So you have infinite amount of storage. The processors are so fast that you can actually do most of your stuff in memory, which is the fastest part, so you don't have to go down into the hard drive, you're in memory. So all these advances in hardware enable the advances in software to come together, plus big data. The amount of data that we've been generating per second in amounts that never existed before that in hundreds of years. And the possibility now to try out mathematical models, that's what algorithms in the end are, and see what comes out of it. So, the next thing was big data. And I'll just go through what I see as legal issues concerning with big data. The first is the source of the data. Where in the world did it come from? That is a big issue, because on the one hand, you want to, when I say, okay, I want, let's say, temperatures in Spain and Madrid as an average, and I use data that is, in the end, actually from Denmark, then that will not help me. So I have to always be careful and know where is the data from, and etc. And that, by the way, is a huge issue in every IT project. In any company or when government decides to build an airport or whatever, everything that involves IT, I always have the problem of where is the data, where did I get it, is this actually what I presume it is? So the source of data, which also then quite quickly leads to the issue of private data, because if it's private data, personal data, then I have different rules concerning it than if it's, say, production data coming in from sensors from my machines or from Amazon warehouses. So there I have customer data, then I have the data of where I stored what in what warehouse, and how do I program my forklifter to go without a driver and get everything in an efficient sequence. So the issue of, is it private data or not? And private data, by the way, and this is, if you want to understand data protection, you have to think of two things. First of all, the issue of connecting the dots. So the German Constitutional Court in the 80s already, on issues of public census, made the decision, okay, data protection is now so closely related to human dignity. And why? Because with computers, and we're talking about the 80s, with computers I can now connect different data points, different little pieces of information, and out of that I can profile someone. So that already in the 80s was an issue. Then the issue of security, data security. Okay, we're used to every few months reading in the newspaper that another 500 million data sets were taken from an insurance company or from a credit card company or from Facebook or whatever. But the issue of security, that is a major issue, because one of the reasons why the security services are not allowed to keep to access telephone data as they wish is because the telephone companies are not allowed to keep the data beyond a certain duration, and one of the reasons is the security of the data. The more data and the more data I centrally collect, the bigger the danger is of there being a security leak for whatever reason, and then of course more damage. So connecting the dots, issue of security. I'm not going to go into more on this because we have a lecture on that, but I just wanted to mention, if you really want to understand data protection, I encourage you to read the first legal article on that, and that was from Louis Brandeis and Samuel Warren in 1890 in the Harvard Law Review. And the issue was, again, technology and law. And the issue there was that the yellow press, newspapers in New York, because of the advancement of photography and printing processes, were able to print photographs in newspapers, and that was spectacular. And what were the photos? Some well-known banker with a dance girl on his arm leaving a dancing hall. And that, of course, was a scandal. So the scandalous photos you were able to publish. And that was the issue of Louis Brandeis and Samuel Warren, the issue of privacy. So we had an advance in technology that ruined concepts of privacy as they existed before you were able to take a photo of a famous banker and put it on the front page, and his wife finds out, oh, he was there with a dancing girl. Okay, so technology there again, and law. Then the issue of clean data. Okay, so when you do a mathematical model and you say, okay, I have this and this and this information, you of course presume that it's not corrupted. Now, corrupted, that's a wide range. That can be technically, it can be that, for instance, just last week I was watching someone in the company, he was trying to transfer data from one storage medium to another, and it was in Excel sheets, and the person who had done these Excel sheets had not done it correctly, so you could not separate the pieces of data. So in actuality, they had to do a kind of rewriting it. So that then is also then not clean data. So the issue, and this is also an issue of warranty and of liability, because if I am licensing a software product or a robot, which in the end is software, that depends on the data, and it depends on data either that the producer has provided to the software or it comes from the customer. And if the data is not clean, then the algorithms will not work, the whole model will not work. So that is always going to be a problem. So a lot of what we fantasize is simply not going to happen, because in real time today, I mean, if you, Coca-Cola or whatever, when they go from one SAP system to another, an upgrade, it takes them months, it costs millions of US dollars, and the main problem in all IT projects is the migration of data. So from my old system to my new system. And you always have problems. But when we're talking about software that I'm not programming, but I'm programming so that it self-learns, so it starts making its own, let's call it, decisions, then if something goes wrong, I have the problem, well, is it in the data? Or is it in the algorithms I wrote so that it was be able to self-learn? So this all becomes rather complex, but these are the things you have to understand if you are thinking about simple things of warranty and liability. And if your clients are in the health industry, pharmaceutical, automotive, insurance companies, banking, these are the industries that within the next, well, actually it's already happening, are changing their business based on software that is self-learning. So this is from a customer side an issue. What is an IBM going to warrant, and where's their liability if something goes wrong? And also on the other side, I is IBM. What can I even warrant here? So this is something that is actually very, that is when we're talking about the big impacts, it's not really that everything will be revolutionized, but we're now dealing with a technology that has its own mind, and you have contracts that have to deal with that. Okay, the next issue is, big data is the foundation of deep learning, so it becomes an economic resource. And now it becomes really interesting. So, how do I deal with that? So the first thing is, I'll be talking, and I have to do this now in 5 minutes or something, is the EU law that is going to come into place. And then if we have another 2 minutes, the EU law that is already in place. Okay, civil law rules on robotics. That is what the EU is discussing now. And any law firm that is interested in dealing with economic matters should have someone who looks into this and maybe gets involved in the legal discussion, because that's the nice thing about the EU. It's always a very transparent process in comparison to national parliaments. And that is, there's always a call for opinions. There's always the possibility of getting into a train and a plane and going to Brussels if you don't have people there already. But I mean, even small groups can do that. You can sit down and you can write a paper and hope that it's read, because thousands of others are writing papers, or hundreds of others. But this is a very, very transparent process. You can actually get involved. And as lawyers, one really should. So I'm recommending a document that you can get in the various languages. I chose English because I'm speaking English, but you can get also, obviously, because the EU document in Spanish or in German or whatever, French. So it's the European Parliament resolution of 16 February 2017 with recommendations for the EU Commission. The EU Commission formed a commission on civil law rules on robotics. Robotics, of course, is not just, the metal arm that moves one thing to another thing in a car factory. That's everything that we would understand as artificial intelligence. So it can be a black box, or it can be something that looks like something with two eyes or whatever. Okay, so what I find really interesting is the introduction. Whereas from Mary Shelley's Frankenstein's monster to the classical myth of Pygmalion, through the story of Prague's Golem, to the robot of Karel Čapek. And by the way, the first use of the word robot is from a play by Karel Čapek in the year 1920. It was already about androids, so machines that had human characteristics, and he called them robots. Who coined the word. People have fantasized about the possibilities of building intelligent machines more often than not androids with human features. So I find this interesting, that a piece of legislation, I mean, this is a non-binding resolution, but it's by Parliament, starts off with the cultural context, the cultural imagination of what artificial intelligence is. So that's, again, really important to understand that our concept of the science fiction of what computers will be taking over society, that is because of the cultural reflection on the word or term artificial intelligence, starting off in the 50s and 60s with all these films. So then let's get to more legal stuff. So still within this resolution, it's non-binding, but it's important, obviously, because in the end the Parliament has to make a decision. Okay, so I'm going to skip to what we're interested in always, and that is liability. So, okay, it's talking about how Robots can now take over tasks that until then were human, like driving a car. Okay, but the development of certain autonomous and cognitive features of robots, of software, in other words, the ability to learn from experience, that's the self-learning, and take quasi-independent decisions. That's the other aspect of self-learning, that a decision is made by the machine and doesn't have to wait for the programmer or the user to push yes or no, but the machine makes the decision, and that's where all kinds of ethical and legal issues come up. Has made more and more robots similar to agents that interact with their environment. So you're getting an independent actor in, let's say, traffic, or in a bank, or making the decision, do you get this can you get this insurance, can you get this stipend, can you get this mortgage? That's being decided more and more, not by a human, aided by machines, but by the machine itself. So you notice I'm using the word machine even though it's actually software, but that's the interchangeable part. Okay, and now, at the end it says, and it's in such a context, the legal responsibility arising through a robot's harmful action becomes a crucial issue. The next presentation will deal with that. So, and then we continue on. So, what they want to make sure, the Parliament wants to make sure, is that whatever legislation is proposed on limitations of liability, the future legislative instrument should in no way restrict the type or the extent of the damages which may be recovered on the sole grounds that damage is caused by a non-human agent. So what they do not want, the Parliament does not want, is that a law is passed and said, okay, if a robot did it and not a human, there's no liability, because liability can only be caused by a human. Yeah, there are these discussions. So already here the Parliament has made a decision, and that is the aspect of human involvement in liability is not the determining factor anymore. If a robot made the decision, it's as if a human had made the decision. Then the next issue, and this is more getting into the nitty-gritty of how you can do liability, but I'll skip that because we don't have the time, and you'll be reading this document if you're interested anyway. Okay, and then I'll just mention this. The actual solution is a liability insurance for every industry that uses robots. If you pay into the compensatory fund, then you're covered by that. So that is an interesting concept. There are no details who is going to run it, etc., etc., but the actual solution, and this is a solution that you're never allowed to write in a legal exam at university, because in the end it's always the insurance company who pays. So we have spent hours and weeks and months learning all this liability stuff, and in the end it's the insurance company. Here they cut to the chase and already say, okay, let's legal out all kinds of stuff. It's going to be an insurance fund that's going to pay. So that I find actually to be quite reasonable. Okay, 2 minutes? Okay, 2 minutes. As I said, it's a big data and becomes an economic resource. If you have huge amounts of data, then you can also do your product development, you can do the research, and that is why Google, Facebook, Amazon, Microsoft, and the Chinese versions of all this are the biggest drivers of research and, they hope in the end, products of artificial intelligence. I mean, if you imagine Google is a search engine and it builds autonomous cars. And it's the biggest funder and driver of that. So you see how these companies are thinking far beyond what their actual business used to be, and that is interacting with people, and by that occasion collecting data so that advertising can be more targeted. That's the actual reason. And what do we see? Oh, they're building robots that can then drive through traffic. Okay, so, and when you're thinking about economics, you're obviously thinking about markets. And we're talking about the EU, so that's the main thing anyway, our market. And anytime you think of markets, I would like to remind you of Adam Smith, who is who started, well, he didn't start modern economic thinking, but one of the major thinkers of modern economics the so-called invisible hand, the market, how it functions. Okay, and then there's this sentence. People of the same trade seldom meet together, even for merriment and division, but the conversation ends in a conspiracy against the public or in some contrivance to raise prices. This is what he wrote in 1776 in his famous book, An Inquiry into the Nature and Cause of the Wealth of Nations. Wealth of Nations is what you usually remember. So, the issue of market and competition, and that those who are in competition hate competition, because if you have less competition, you have higher profit. Why? Because either your costs are lower, or your prices are higher, or both, which is the case. So that is what the EU deals with at its heart, and that is competition law, because the aim of the EU is to create the European single market, or internal market, or common market. The words changed over the decades, and that's the fundamental principle of the EU. That's why we have all these problems with Brexit and things like that. And therefore, at least in my opinion, as a competition lawyer, EU competition law is at the heart of EU law. And I won't go into all kinds of wonderful cases, but just to say what the issue is, that competition law, and that means the European Commission, when it enacts a fine or intervenes in a merger and acquisition, or if there's forbidden pricing and or collusions of companies, etc., is to make sure that it has an impact on effective competition structures, so that there is competition structures, which means no monopolies and things like that, if possible. And the competition rules are designed to regulate the forces of supply and demand, because in the end, that's always what determines pricing and what's offered as products, is supply and demand, to preserve the process of workable competition. So not perfect competition. And this last sentence, that workable competition, that's the economic theory of the EU, is that it produces innovative efficiency. So it drives innovation if you have competition. And that's how we end up then with artificial intelligence. So to support artificial intelligence, you need to be strict with the competition rules towards Facebook, Google, etc. How do other companies that have not amassed those huge mountains of data, how do they get access so that they can produce and develop products of artificial intelligence? Thank you.